Today we are starting module 4, that is the seed forming processes. Okay, so under module 4, this module is typically designed, especially designed for seed metal forming processes. We already know that there are two types of metal forming processes. One is bulk metal forming, which we have covered in the module 3. And in module 4, we are going to discuss about a second type of forming processes, which is called as sheet metal forming processes. Okay, so as the name indicate, in the forming operations are generally performed on metal sheets, strips, or coils. Okay, so this was discussed in module 1, that sheet forming processes have low volume to surface area ratio or high surface area to volume ratio. Okay, so your starting metal have low volume to surface area ratio. Okay, so this way we can distinguish these sheet forming processes from bulk forming processes. Okay, so these seed forming processes are also called as press forming processes, because generally press forming or press working processes, because presses are used to perform these operations. Okay, and during the operation, the part which are produced, these parts are called stampings, and the toolings which is used, that is the press tooling which is used, it has mainly two component. It has punch and die. Just a minute, I will call one call, important. Sorry for the interruption. I think I'm back. Okay, so these processes, these toolings that are used in presses are called punch or die. Okay, so sometimes this punch also have some shape. Okay, so in some books you may find instead of punch, it may be written as upper die or lower die. Okay, so we will try to understand what is called sheet. Okay, how these sheet metal working processes are defined. Okay, so one thing that is the important, that these operations or forming operations or cutting operations are performed on relatively thin sheets. Okay, so what is sheet? The thickness of sheet typically varies from 0.4 mm to 6 mm. Okay, so there may be sheets even less than 0.4 mm, but then this is called as foil. Then this is no more called as sheet, because this dimensions, if it is less than 0.4, then it is called as foil. Okay, but if this dimension is in between 0.4 mm to 6 mm, okay, then this metal workpiece is called as your sheet metal. Okay, so if you take this dimension into inches, then it comes around 1 by 64 inches to 1 by 4th of inches. Okay, so this is how we distinguish between sheets, foil, and plates. Okay, so what is plate? Plate is nothing. Plate is having thickness of greater than 6 mm. Okay, so foil is having dimensions, that is the thickness less than 0.4 mm, and the sheet is having dimensions, that is the thickness, which varies from 0.4 mm to 6 mm. Okay, if this thickness is more than 6 mm, then the sheet metal, the sheet piece is called as plate. Okay, so this way we can distinguish the different stock, that is the plate stock, seat stock, or foil stock. Okay, so sheet metal working processes are generally restricted to 0.4 mm to 6 mm. Okay, so whatever the process we are going to discuss in the module 4, the dimensions of workpiece, that is the thickness of your initial metal sheet, will be 0.4 mm to 6 mm. Okay, generally these operations are performed as cold working. Okay, and as you know, the thickness of these sheets are very thin. Very low forces are required to perform these operations. Okay, while in the case of bulk forming, we have discussed, we need large amount of forces, that is a high magnitude of force is required to deform the metal under the bulk metal forming processes. But in the case of sheet metal working processes, since the thickness of sheet is very low, we require less forming processes. Okay, so before going into the deep, we will discuss that what are the different sheet and plate metal products. Okay, so these I have listed out few metal parts or products which you can you normally see in your daily routine. Okay, so you can see that there are metal products or sheet metal products in automobile industries or trucks. You can find in aeroplanes. Okay, you can find sheet products in your railway cars, locomotives. There are other areas, farming and construction, small and large appliances. Okay, even your mobile which you are using, it is also having so many sheet metal components. Okay, you can find in your houses also, there are so many components which are produced using sheet forming processes. Okay, so you can find these sheet forming products in your office furniture, computer and office equipment. Okay, so in your computer itself, you can see there is lot of sheet metal work. Okay, and these products are produced using multiple forming sheet metal forming processes. Okay, so if you Google it, that the contribution of sheet forming processes, you will find that the sheet forming processes includes a large amount of GDP as compared to any other manufacturing processes. Okay, so as far as the scope is concerned, this your module 4 is very important, and it has a very large scope in the industry. Okay, so what are the advantages? We will come to the advantages. What are the different advantages of sheet metal forming sheet metal parts? These sheet metal parts have high strength. Okay, they have sufficient strength, as well as the dimensional accuracy is high as compared to any other manufacturing processes. Okay, so since the dimensional accuracy is high, we also have good surface finish. Okay, and since your metal sheet metal parts are, you know, the initial block is having thin sheets, so very low forces are required. And since the very low forces are required, we need not have a heavy machinery is not required. We need only small presses for forming the sheet component. Therefore, the cost of your machine is reduced, and therefore your production cost is reduced. Okay, so the sheet components have a relatively low cost. Okay, and because of the simplicity of operations, these seed forming processes can be used for large quantities. That is for these are economical for mass production operations, okay, which are available in market. Okay, so these are the advantages which I have listed out of sheet metal forming processes. Okay, so I have listed out few here. I have listed out few metal forming processes which we are going to discuss in under your module 4. Okay, so these processes are bending, stamping, deep drawing, stretch forming, spinning, and incremental forming. Okay, so these sheet metal forming processes are listed out in your syllabus. So we will discuss one by one. We will try to complete at least bending today. It is a very small topic. Okay, so we will try to complete bending process today, and we will cover up stamping and deep drawing in the next, and stretch forming and spinning, incremental forming in the another lecture. Okay, so we will try to finish the module 4 in almost 3 or not more than 4 lecture. Okay, so today we will cover bending. Okay, so what is bending? As the name indicate, we are bending because this is related to seed forming processes. So what we are doing basically, we are bending seeds only. Okay, so it is not bending of bar or bending of I cross section, L cross section. We are typically discussing about bending of metal seeds. Okay, so in some books you may find it is written as bending operation or bending process, but the sense is same. Okay, so under bending, what we are doing, bending is the forming of sheet metal by the application of force which exert pressure on a certain length of material, either at a certain point or linear as an evenly distributed bed. Okay, so what happens as soon as we apply forces on certain portion of sheet, some bending moment is generated, and this applied force is sometimes also called as bending moment. Okay, and this bending moment causes the uh, the deformation, that is the bending of sheets by a certain angle. Okay, sometimes this is called as degree of deformation. Okay, and this bending of sheet metals is done with the help of press brakes. Okay, so if you google this term press brake, you will find large machines which are capable of deforming sheets of very large dimensions. Okay, so this is generally done with the help of press brakes, roll bending machines, embracing or coining machines. Okay. Okay, so this here you can see how this bending operations is performed. Okay, so initially this your metal sheet was straight. Okay, and by the application of some forces, here you can see it has been bent by a certain angle. Okay, so this angle because since this initially this was in a straight line. Okay, and after bend this has come like this. Okay, so here we can see that the bending angle, this A is greater than 90 degree. Okay, so here it is notable that uh, as soon as we bend, some kind of stresses are developed under the portion which is under the deformation. Okay, so we can see here this portion is under deformation. Okay, this particular portion which is being bent, this is under deformation. Okay, and here we can see some portion, that is the upper portion is this tensile stresses are developed, and in the lower side here you can see compressive stresses are developed. Okay, so here we can see there is a combination of stresses, that is the tensile stresses as well as compressive stresses in the bending operation. Okay, and because this side there are tensile stresses, and on the another side we are having compressive stresses. Okay, so there must be some line on which there is no stress. Okay, so no stress is developed at some line. That line or that axis is called as neutral axis. Okay, so here it is mentioned that this is your neutral axis, whereas no compressive or tensile stress is developed. Okay, or there is no change in the length of your uh, metal block, or your metal sheet on your neutral axis. Okay, so length of your neutral axis remain the same even after your bending operation is completed. But here you can see, beyond this neutral axis there is elongation, and below this neutral axis there is compression. Okay, so this way we can see that both kind of stresses are developed when we are performing bending operation on your seats. Okay, there are different terms you can see here, which this is called neutral axis, this is your compressed metal, and this is your metal which is under stretching. Okay, so this is how this bending process is carried out. Now we will come to the different types of sheet metal bending. Okay, so there are two types of bending processes. First one is V bending. Okay, and another is edge bending. Okay, so as the name indicate, V bending is performed with a V shaped die, edge bending is performed with a wiping die. Okay, okay, so we let us come to the V bending process. Here you can see under V bending process we are having V shaped die. Okay, this is die, this is your punch. Okay, so as soon as this punch moves towards die, your seat is deformed in the shape of die. Okay, since the die is having V shape, so the metal block or your metal sheet is deformed in the shape of die. Okay, that is the shape of V shape is produced. Okay, so this portion is your die and this is your punch, and it comes with a certain velocity, and which results into the application of force on your sheet metal. Okay, so this V bending operation, this is generally used in low production. It is performed using a press brake, and since the design of V shaped die is simple, and therefore these are less costly or inexpensive. Okay, which results in the low cost of your product. Okay, so this way we can understand how this V bending is performed. Okay, now we will come to the edge bending operations. Okay, so under edge bending operation, what is being done, we can see here, we some punch, this edge of your sheet metal is wiped off using your one tool that is called punch. Okay, so since this punch is moving from our from top to bottom, what will happen, this will wipe off this portion of sheet, and this will bend like this. Okay, so here you can see this is before starting the operation, and this is after the completion of operation. So here you can see this seat strip has been wiped off using this punch. Okay, so as soon as the seat is wiped off, the metal, the seat is bended at the required angle. Okay, so in edge bending, it is, since it is a very quick process, it can be used for high production. Pressure pad is required. Okay, to stop the movement of punch beyond a certain point. Okay, So in the case of edge bending processes, because it has to be performed on a sheet. Okay, so this die shapes are complicated. Okay, and as we know, the cost of die will increase as with the complicacy of die. Okay, so these die are costly, so which results in the increase in the cost of products which are produced using your edge bending process. Okay, now we will come to the next topic, that is the spring back in bending. Okay, so spring back is nothing, it is the increase in the angle of bent part relative to the included angle of forming tool after the tool is removed. Okay, so let us take the example of uh, uh, your this V bending process. We can see here we have applied certain force, and as soon as we remove this punch is removed from this place, what happens? This uh, this your seat is uh, uh, this seat shows some spring back. Okay, so because why this spring back is coming? The spring back is coming because of the elastic energy which remains in the bent part. Okay, because of this elastic energy, what is happening? It is creating some increase, some decrease in your bent part. Okay, decrease in angle of your bent part. Okay, so in order to compensate this decrease in angle of bent part, what we have to do? We have to increase some portion, some bent angle. We have to additionally increase some bent angle in your die design. Okay, so if we include this spring back while designing the die, the accurate product will be you will be will get as a final shape after the application of this V bend. Okay, so similarly we can apply uh, this concept of is additional forming angle to be included in the case of other bending operations like edge bending operations. Okay, so this way we can compensate with the process that is compensate with the issue of spring back. Okay, this is all about your bending operation. Okay, so I will stop here.